video, we're going to have a look at multiplying complex numbers. So go ahead and try this particular example on your own before we take it up together. What you're being asked to do is multiply 5 plus 3i times 2 minus 7i, and then add what you get when you multiply 9 minus 3i times 5 plus I. In order to do this, go ahead and do the expansion parts first. So expand 5 plus 3i times 2 minus 7i, and similarly expand 9 minus 3i times 5 plus I. In order to do the expansion, remember you're using your usual rules for expanding that we learned when dealing with other expressions such as x plus 2 times x plus 3, where what you would do is apply the rule FOIL. So multiply first, outer, inner, and last terms to make sure that each term in one expression multiplies each term in the other expression. So you're applying your usual rules for expanding here. Once you've done the expansion, go ahead and collect like terms. A key thing to keep in mind is that when you multiply an I by another I, so you get I squared, because I is root -1, when you multiply them together, you end up with -1, and that's a real number. So I squared is a real number. It's just equal to -1. So once you've done the expansion and realize that I squared is -1, all you have to do is collect like terms. So just collect all the real terms together, collect all the imaginary terms together, and you've got your final result, your final complex number. Go ahead, try it. We'll continue once you're done. So let's have a look at the solution. So first of all, let's go ahead and write out the problem, which is 5 plus 3i times 2 minus 7i plus 9 minus 3i times 5 plus I. Remember, what we're going to be doing is FOIL, so we need to multiply the first terms, the outer terms, the inner terms, and the last terms. And we need to do that for 5 plus 3i times 2 minus 7i, but also for 9 minus 3i times 5 plus I. So again, we're going to have to do first, outer, inner, last. So let's go ahead and do this expansion. So multiplying the first terms, we have 5 times 2. For the outer, we have 5 times -7i. For the inner, we have 3i times 2. And for the last, we have 3i times -7i. So that was the result of multiplying the first two numbers together. Now let's move on to the next two numbers, 9 minus 3i times 5 plus I. We get 9 times 5 from the first terms, we get 9 times I from the outer terms, we get minus 3i times 5 from the inner terms, and we get -3i times I from the last terms. And again, I've done everything as addition, although you can think of it as subtraction. You could do -3i times I. I've treated it as plus -3i times I. It's the exact same thing. So now what we have to do is simplify as much as we can so that we can then group like terms. So 5 times 2 is 10, 5 times -7i is minus 35i, 3i times 2 is plus 6i, 3i times -7i is minus 21i squared, 9 times 5 is 45, 9 times I is simply 9i, -3i times 5 is minus 15i, and minus 3i times I is minus 3i squared. Before we can go ahead and collect like terms, let's deal with the I squared terms. Remember, I squared is just -1. So what we're going to do is simply rewrite everything, but every time we have an I squared, we're going to replace with -1. So we have one occurrence of that, and then we have a second occurrence of that, so we're going to replace I squared again with -1. And just to emphasize, let me highlight this. Again, we've replaced the I squared with -1 in this step. So next, continuing on, we just want to group like terms together. First, actually, before we do that, let's just multiply out those -1s that came from the I squareds by the appropriate number in front of them. So we have 10 minus 35i plus 6i minus 21 times -1 is positive 21, plus 45 plus 9i minus 15i, and -3 times -1 is positive 3. You could have already started collecting terms in the previous step. For example, we had negative 35i plus 6i. You could have combined those. I'm just trying to do this as step by step as possible to make it easier to follow along. So now let's continue to the final step, which is to collect like terms. Let's have a look at what our real terms are. So the real terms without the i's in them are the 10, the 21, the 45, and the 3. So all the terms that have just been underlined in red. So what we have, if we combine these together, 10 plus 21 is 31, plus 45 is 76, plus 3 is 79. So that's the real component of our number. Now for the imaginary component, we have all the remaining terms, which I'm just going to underline in blue. So negative 35i, positive 6i, positive 9i, and minus 15i. So if we take negative 35 plus 6, that's going to be negative 29, plus 9 is negative 20, minus 15 is negative 35. So we end up with negative 35i. So that's the imaginary part of our complex number. So altogether then, we end up with 79 minus 35i as our final answer. And again, remember that all we did to complete this example was expand like we normally would, realize that I squared is equal to negative 1, and then collect the real components of the number and the imaginary components of the number separately and combine them to form our final complex number.